students, this video will talk about different types of vectors. By taking suitable examples, I will tell you how we can categorize the vector quantities. For instance, when you two friends are moving in one direction, both are moving towards east, both are walking towards east. You have the velocity 4 meters per second towards east, your friend is walking at a rate of 5 meters per second towards east. Your velocity and your friend's velocity vector, both the velocity vectors are having some direction. We call it parallel vectors. Parallel. When you and your friends both move with velocities v1 and v2, v1 is 4 I cap meter per second, v2 is equal to 5 I cap meter per second. I cap means towards east or towards positive x direction. The directions are equal, but their magnitudes may or may not be equal. Then only you can say that these two vectors are parallel. So two vectors are parallel only when they are pointing along some direction. When v1 and v2 point along some direction, we call them parallel vectors. Now we will talk about antiparallel. Antiparallel vector. If you move towards east, the velocity v1 is 4 I cap meter per second, and your friend is moving towards west with the velocity of 5 meters per second. In which direction? Minus I cap direction. Minus I cap means towards west or negative x direction. Then v1 and v2 are called antiparallel. Antiparallel vectors. When they point in opposite directions. If these two velocities are having same magnitude, suppose, when v1 and v2 are parallel, but they have some direction, therefore they are parallel. If they have some magnitude, we can call these two vectors exactly equal. So equal vectors are having both some magnitude and some direction. v1 is exactly equal to v2 when magnitude of v1 is equal to magnitude of v2, and they act in same direction. Or in other words, we can say that two parallel vectors having same magnitudes can be called equal vector. Equal vectors must be parallel, but parallel vectors may or may not be equal vector. Now let us talk about the negative vector. Two vectors are called negative vector only when they are pointing in opposite direction, but they must have equal magnitude. Say you are moving in this way with the velocity 4 meters per second towards east, and your friend is moving in other way with velocity of same magnitude, but direction is opposite. V1 and V2 are negative vector in this case. These two vectors are negative. When they are having same magnitude but they have opposite direction and they point oppositely. This is called negative vector. By using the concept of negative vector, let us take another type of vector called null or zero vector. Zero vector or null vector. For this purpose, let us a simple example. I pull this marker pen in this way. When I pull this marker pen in this way, it will move in this way. When I pull it in this way, it will move in this way. When I pull both sides with equal and opposite forces, it won't move at all. So I can say that this force plus this force is equal to zero force. This object you are pulling with a force F1, say this is 4 Newton in this direction, and you are pulling in the opposite direction with the force F2, and minus I cap is the direction, 4 is the magnitude, Newton, and effect of both F1 plus F2. That's the net force. Net force. This we can call additional vectors, will be discussed in my next video in detail. So the net force acting on the object is zero. But it's not simple zero. It is zero vector or null vector. So null vector has magnitude 0, but the direction is arbitrary. When you pull the object in both directions with equal forces, it will be at rest. It can have any direction. When you push it in a particular direction, it will go on moving in that direction with constant velocity. So that will be cleared in the chapter of force. So using that idea of two forces acting in opposite direction having equal magnitude, we can understand that the combination or the resultant or the addition of these two forces will give you zero force. I mean, it's a null vector. Null vector has magnitude 0, but it has any arbitrary direction. We cannot say in which direction exactly this particle is moving. This is at rest. If you tilt it in any direction, to move in that direction with that velocity. So this is an example of force I have taken to explain the concept of null vector. However, you can add any two negative vectors to get a null vector. Now we will take another type of vector called collinear. Collinear vector. For this purpose, let us take a rope tight here. You pull the rope in this way, and you can tie the other end of the rope at this point. Another guy is pulling the rope in this way. Another guy is pulling the rope in this way. You are pulling this rope with force F1. Your friend is pulling this rope with force F2 in this direction. Another guy is pulling the same rope in this direction with force F3. These three forces are acting along the rope. These three forces are acting along the rope. F1, F2, F3. Act along the rope, along the same line. Therefore, these three vectors or three forces are known as collinear forces or collinear vectors. The vectors are collinear only when they act along the same line. After collinear vector, let us define coplanar vector. If three vectors, let us assume vector 1 is the force 1, another vector 2, or the second vector is force 2, and the third vector is force 3. Force 1 F1, force 2 F2, and force 3 F3. These three vectors or three forces act at a point. And all these vectors, all these forces are acting in the plane of the board. Therefore, we can call them coplanar vectors. The vectors must act in a plane. Therefore, F1, F2, F3, you can add another force F4 also. These forces of the vectors are coplanar. Then we can go for non-coplanar vector. Suppose two vectors, one is acting in xy plane, another vector is acting in y plane. Another vector is acting in xz plane. This plane is XY plane. This plane is XY plane, and this plane is YZ plane. These three vectors, F1, F2, and F3. These three vectors act in different planes. Vector F1 is acting in XY plane. Vector F2 is acting in YZ plane, and vector F3, X, in XZ plane. Since the three vectors are acting in different planes, these vectors are known as non-coplanar vector. Since F1, F2, and F3 act in XY, YZ, and XZ planes, respectively, have been seen three different planes. We call them non-coplanar vectors. Therefore, F1, F2, F3 are non-coplanar.